Hey guys, welcome back to Limitless Learning. Today we will be talking about systems of equations and go through some examples. Before we dive into systems of equations, we must ask, what are systems of equations? Well, they are essentially systems of linear equations which consist of two or more equations which contain a common solution. As a graphical representation, we have two equations, y equals to negative x plus 2 and y equals x, in this system, which is indicated by the brace. When you graph the two equations, we know from prior knowledge that the solution to two equations graphically is where it intersects. So after graphing the two equations, we find that they intersect at the coordinate 1, 1, which is our solution. Also, as we know coordinates are composed of an x-coordinate and a y-coordinate, x and y in this case equals to 1. Let's try an example. Say for instance we have a system of equations in which our two equations are y equals to 1/2 of x minus 2 and y equals to negative 2x plus 3. What is the solution of this system represented graphically? Pause the video, try this problem on your own, and come back once you have finished. Alright, so let's first graph the 1/2 of x minus 2 equation. So we would start at negative 2, and we would just have a slope of 1/2. So up 1, right 2, up 1, right 2, and then here it would just be left 2, down 1. Alright, so let's just draw a basic line to connect this. And this is just to clarify 1 equals to 1/2 of x minus 2. Alright, so now we have this, we can graph the second equation. So we would start at 3, and it would just be down 2, right 1, down 2, right 1, down 2, right 1. Alright, so and then this is just y equals to negative 2x plus 3. Alright, so as you can see, the point in which these two equations intersect is right here at 2, negative 1. So our x is equal to 2, and our y is equal to negative 1, and 2, negative 1 is our solution. Alright, so we saw graphically how to solve systems of equations, but in most cases it is time consuming to draw graphs for every system. Hence we can use the substitution method, which states that if two expressions are of equal value, then one expression may replace the other expression or vice versa. Let's look at an example of this to get a better idea of what this looks like. So for example, we have two equations in the system where y equals to 2x plus 4 and y is equal to 3x plus 2. So as you can see, both expressions are equal to y, right? So if both are equal to y, you can make them equal to each other. So the equation to solve would now be 2x plus 4 equals to 3x plus 2. So as now we just have to do simple algebra, we would subtract negative 3x or 3x from the right side onto the left side, which would give us negative x, and we would subtract 4 from the left side onto the right side, which would give us negative 2. Now to get x as a positive constant, we would divide each side by negative 1, which will give us x equals to 2. So we can't just stop here though, because we only have the x coordinate. So now we have to plug the x value in back into one of the original equations to get our y value. So in this case, I'll just do the first equation. So I'll do it right here. Y is equal to 2x plus 4, and we're going to substitute this x equals to 2 value into this equation. So it would just be y equals to 2 times 2 plus 4, which would ultimately give us 8. So now we have the x and the y value. So our solution for this system of equations is 2, 8. Let's look at one more example of this. If we have the system of equations y equals to 5x plus 6 and y equals 4x plus 3, what is x and y equal to, and what is the ultimate solution? So, just like last time, pause the video and try this one on your own. Alright, so similar to the last problem, both expressions are equal to a common solution, which is y. Hence, you can make them equal to each other, which would yield 5x plus 6 equals to 4x plus 3. Now it's just simple algebra, so I'll subtract the 4x from the right onto the left side, which will just give us x, and I will subtract the 6 from the left side onto the right, which would give us negative 3. So now that we have our x value, we can plug it back in to one of the original equations. I'll just do the first equation, so that would be y equals to 5x plus 6, and if we substitute x equals to negative 3 in the equation, we'll get 5 times negative 3 plus 6, which ultimately equals to negative 9. Oops, sorry. So we have our y and x value. So now our total solution for the system of equations would be negative 3, negative 9. Lastly, while the substitution method is a great method, expressions will not always be equal to a common solution. Hence, we will need to use the elimination method for those occurrences, in which you add or subtract equations in order to eliminate either x or y to find the other variable's value. Additionally, you might need to multiply one or both of the equations by a value in order to properly cancel x or y. Let's look at an example to get a better sense as to what this looks like. So, we have the solution, or the system of equations, 2x minus 2y equals to 8, and x plus y equals to 1. So, in this case, we have to multiply one of the equations to cancel out a variable. So in this case, I'm seeing that there is a factor of 2 between the second equation and the first equation. So if I try to multiply just this equation by 2, I would get 2x minus 2y equals 8, since nothing's changing with the top equation. But with the bottom equation, it would be 2x plus 2y equals to 2. Now, if I try to add both together, which is what you do to cancel out a variable, you'll find that this y would cancel because it's negative 2y plus 2y, which equals 0. But here it would be 4x equals 10. So in this case, it would just be simple algebra at this point, which ultimately gives me x equals to 5 halves, or 2.5. Alright, so now, just like last time, I can plug this value back into one of the equations. And if you're doing this on a test and you don't have much time, I would recommend to choose the equation that you feel like would be less less calculations. So in this case, I see that x plus y equals 1 seems like a way easier equation to use. So I'm going to use that equation. So by substituting substituting 5 halves for x, I'll get 5 halves plus y equals 1. And really, 1 is just 2 halves, right? So I can replace that and subtract 5 halves from the left side onto the right, which would give me y to be negative 3 halves, or negative 1.5. So we have our x and y values, so our total solution for this system of equations is, I'll just put in fraction form, 5 halves, negative 3 halves, or if you want it in decimal form, it would be 2.5, negative 1.5. Alright, so now that you have a better idea of this method, let's try a few more examples. For the first example, we have a system of equations comprised of two equations, y equals to 5 minus 2x, and 4x plus 3y equals to 13. So for the first equation, we can see that it is not in the same arrangement as the second equation. So to make canceling a variable easier, we can rearrange the first equation to be 2x plus y equals to 5. And this can just be done by realizing that we can add this negative 2x onto the left side. And now that we have our variables on the left side and our constant on the right side, we can now try to find a factor to cancel one of these variables out. So immediately when I'm investigating these relations between the x and the y on both equations, I immediately realize that the difference between the 2x and the 4x is a factor of 2. And if I'm trying to cancel this out, I would realize that by multiplying the top equation by -2, I would make the x's -4x, right? Since -2 times 2 is -4. And when added together, it would cancel to 0. So that's exactly what I'm going to do. I'm going to multiply the top equation by -2, which will give me -4x minus 2y equals to -10. And the bottom equation would just be the same. And when added together, just like I told you, the -4x and 4x would cancel out. The -2y plus 3y is equal to y, and -10 plus 13 is 3. So we have y equals to 3, but now we have to plug this y value back into one of the original equations to get our x value. So in this case, I'll use the top formula. So we have 2x plus y equals to 5, and I'm going to put the value that we have, or that we got, which is y equals 3, into this equation. So now it's 2x plus 3 equals 5. And I'll subtract the 3 from the left side onto the right side. So we can have our variables on one side, which would give us 2x equals 2. And to make this x by itself and get rid of the 2, we would divide both sides by 2, which would give us that x is equal to 1. Now that we have both our x and y value, we can say that our solution for the system of equations is 1, 3. For questions 2 and 3, try both on your own by pausing the video and come back once you have finished both problems. Alright, so for number 2, you can immediately see that the arrangement is symmetric with both equations, since the variables are on the left side with the constants on the other. So there's no rearranging to be done, so I'm going to try to find a factor. However, if you realize that there are no factors between the x's on both the top and the bottom equation and the y's on both the top and bottom equation. So in this case, the best way to do it is, in this case, I'm going to use the y variable. So I would multiply the top by 5 and the bottom by 2, because in this case I would get, if I do 5 times 2, I would get 10y, and if I multiply -5 by 2, it would be equal to -10y, and if I add those two together, it would equal 0. So that's exactly what I'm going to do. I will multiply the top equation by 5, which will give me 20x plus 10y equals to 70. And the bottom equation, if I multiply it by 2, I would get 6x minus 10y to be equal to -44. So if I add these two equations together, I would get 26x, and obviously the 10y and -10y would cancel out, and then 70 minus 44 is 26. So to make sure that the x is by itself, I would get rid of the 26 by dividing 26 on both sides, which makes x to be equal to 1. So just like any other problem now, I would just substitute this x equals to 1 value back into one of the original equations. So for this instance, I will use the top equation, or 4x plus 2y equals to 14. And then I'll just substitute x with 1 now. And then that would just be 2y to be equal to 10, since 4 times 1 is 4, and if you subtract 4 from the right side onto the left, it would just be equal to 10. Now to get the y on its own and to get rid of the 2, I would just divide by 2 on both sides, which would give me y equals to 5. Now that I have my x and y variable, I can now have the coordinate, which is our solution. So our solution for the system of equations is 1, 5. Alright, so for the third example, I see that all the variables are on the right side, on the left side in this case, and the constants are on the right side. So now I'm going to try to find a factor so I can cancel anything out. So for the 3x and 2x, there's no factor that I can multiply just one equation by. However, I realized that if I multiply the top equation by -3, that would give me negative 3 times 2y, which is equal to negative 6y. And if I add that two equations together, I would get 0 for y, since negative 6y plus 6y is 0. So that's exactly what I'm going to do now. So I'll multiply the top equation by negative 3, which will give me negative 9x minus 6y to be equal to negative 27. And the bottom equation will just be left alone. So if I add these two together, I would get negative 9x plus 2x, which is negative 7x, and negative 6y plus 6y is 0, and negative 27 plus 6 is negative 21. So now to get x by itself, I would divide by negative 7 on both sides, which would equal 3. So now x is 3. I would plug this value back into one of the original equations. So in this case, I'm seeing that the easier one would be 2x plus 6y equals 6, since there's less calculations to do with x. So now I'm going to plug in the x equals to 3 value into this equation. So that would be 2 times 3 plus 6y equals to 6. And 2 times 3 is obviously 6. And if you subtract 6 from both sides, that would just be equal to 0. So it would just be 6y equals 0. Now, in order to get the y by itself, I would just divide on both sides. Obviously, 0 divided by 6 is 0. So y is equal to 0. So now that I have my x and my y, the solution for this equation is 3, 0. Thank you guys so much for watching. If this helped you, like the video and subscribe for more content. Leave your comments down below if you have any questions or any ideas as to what videos we should make, and we'll see you guys in the next video.